Hey guys, I'm Dr. Kieran Johnson here, quantum biologist. I've got a product which is pretty amazing. It comes out of Manuka honey. It's called O-Behave Empowering Healing. It produces something that's known in science as a hydroxy radical. Biology uses to break itself or cells back down into CO2 and water. It's part of our natural death regeneration system called apoptosis.
Drop the bass.
Hi, I'm Dr. Kieran Johnson, the creator and founder of O-Behave. Understand how many particles per mil I have in my product. My product is quite strange, and it is based on the fundamental principles of how light interacts with matter. I can go into some details, but really the upshot is it's very hard to use light-based methods to analyze something that uses light as a source of energy which changes the structure of the material itself. Colloidal nanoparticles that I'm isolating out of Manuka honey. The light responsive nature of these materials meant when you use particular frequencies or spectroscopy techniques using light, you are interacting with the system in a way in which it's changing its composition over time, because the energy of the light being used triggers physics and chemistry reactions within the material. When I was studying honey, I started using some skills and techniques that I had developed over a number of years as a VJ at dance parties. I started videoing and filming what was happening under a microscope. The materials that were being generated as part of this light energy system that is inherent within Manuka honey. So Manuka honey has royal jelly proteins. Those royal jelly proteins have been analyzed, shown to be around 100 nanometers in size. And the role MGO plays in inhibiting glucose oxidase, so preventing the formation of hydrogen peroxide. So without hydrogen peroxide, Manuka honey has to kill its bacteria in a different way, and it uses a special process called photo-Fenton chemistry. So this photo-Fenton chemistry is reliant on the ability of light to interact with an aromatic ring of the various phenolic compounds, but also the other electron donating compounds such as glyoxyl, dihydroxyacetone, and methylglyoxyl, where single atoms of iron can interact with the electron donating groups, pi electrons, or the free electrons on oxygen in the methylglyoxyl or dihydroxyacetone. The interactions that are occurring allow the photoreduction of Fe3 to Fe2, and under those conditions the iron is then able to react with hydrogen peroxide to produce what's known as a hydroxy radical. The amount of energy, 1200 electron volts. The half-life of a hydroxy radical is around 1/1000th of a second. So you could say that is not really biology, but it's physics. It's the physics that's happening within the Manuka honey that's responsible for its potent antimicrobial activity and its ability to really kill a whole wide range of things. If we isolate the particles, which is what I'm doing, and that's my real, I guess, key skill as a protein biochemist, figuring out how to do industrial purification of proteins, and apply those concepts to, well, it requires light for activation, so therefore using it topically. So what I've really done is develop a topical energy spray to go and say, well, actually, I'm going to be using high energy electrons to cause the destruction, really, of bacteria. So your biology has been doing this for a long time, and uses hydroxy radicals for that exact purpose in apoptosis as a way of biological recycling. So the technology that I've developed is really just a method of purification and understanding what's going on in this light-based energy system